Our today's topic is radians, angular measurement in radian. We know that a circle is having 360 degree angles if we talk about the degree. From where a circle got 360 degree? Around 1500 BC, the Egyptians, they were knowing that the length of the day is around 24 hours. And in their time, this 24 hours all hours were not equal. Greeks, they made an hour equal. And Babylonian, they divided hours into 60 minutes and 60 minutes into 60 seconds. Now, interesting fact about this is that the Babylonian, they were knowing that the equilateral triangle, having all sides equal and all angles equal, this equilateral triangle. And they gave this measurement 60 degree to each of these angles. They gave it 60 degree. They were knowing very interesting fact that a regular hexagon consists of a 1, 2, 3, 4, 5 and 6 equilateral triangle. And that triangle, if this triangle is having a circumcircle, its radius is exactly equal to the side of these triangles. So they gave this idea that this 60, 60, 60, 60, 60 and 60, that this angle is 360 degree. So that's how circle got its 360 degree. So we can divide a circle into 360 part. If I divide this circle into 360 part, then each part, if it is this much, this is called 1 degree. And it's another fascinating fact that in olden times, 1 year was equal to 360 days in ancient times. It is only that in 11th century, the Persian, they calculated the 1 year is equal to 365 point something 219 days. That the Persian calculated. During Roman times, the length of the month was calculated from new moon to another new moon, and it was supposed to be 29 days or 30 days. So that's why they come up with the idea of 30 days in a month and 360 days in a year. Now we are talking about the degree here. So when we divide a circle into 360 parts, then what part is equal to 1 degree? Now what is a radian? If I draw a circle of radius 1, this is called a unit circle. Then its circumference, the formula of circumference is 2 pi r, r being 1, so it is equal to 2 pi. So if this is 1, this is 2 pi. So radian is a measurement when I take in terms of pi. So you can see that this complete is 2 pi, so half is this is pi. So this circumference is approximately 3.14. So 1 radian is roughly this angle, and radian is an angle where all this side and this sides are equal. The length of this arc is equal to the radius. For example, if I make an equilateral triangle, if this is an equilateral triangle, I know that each angle is 60, 60 and 60. Instead of this, if I bend it, if I make an arc of it, then definitely this angle will reduce. So it will be less. So that's why this angle is not 60 because of this arc, so it is less than 60. So 1 radian is less than 60, and if you calculate the value of radian, what you have to do is, this complete angle is, if we talk about degree, it is 360 degree, and if we talk about radian, it is 2 pi radian. So we can say that 360 is equal to, degree is equal to 2 pi radian, and radian will be equal to 360 over 2 pi, that is 180 over pi. So that is equal to, so it is 57.295. Roughly we calculated 57.3. Radian is represented by small c. You can represent it by radian, but hardly it is represented by capital R. So this angle is 57.3. This is degree, that is equal to 1 radian. So you can see the difference in these two. This angle is 1 degree, this angle is 1 radian, this angle. And if we talk about gradient is, if I divide a 90 degree angle into 100 parts, so I divide it into 1, 2, 3, 4, 5, roughly like 100 parts. So this is small angle. This is small angle is gradient. So in radian, either we write angle in terms of pi or we write angle in terms of decimal. You can see that this one is pi over 2, this one is pi, this angle here is 3 pi over 2, and this complete angle is 2 pi. Now if I write in terms of decimal, then we know that the angle, this angle is 3.14 and the complete angle is 6.28. So we can divide a radian into 1, 2, 3, 4, 5 and 6. It's not equal, but 1, 2, 3, 4, 5, 6 and this, because it is 6.28. So a circle is having roughly 6.28 parts, and one part is called 1 radian. And if a circle is having 400 parts, so one part is called gradient. So once again I am repeating, if a circle is having 360 angular parts, then one part is 1 degree. If a circle is having 6.28 or 2 pi parts, so it is 1 radian. And if a circle is having 400 parts, it is 1 gradient. The conversion table is very easy. The relation between degree over 180 is equal to radian, whatever radian over, we know it very well, so we can write it just pi, and is equal to gradient, we have g over 200. We can use this. We are just going to study this relation and take some questions. Now let's compare between degree and radian. You know that radian is written in two forms. For example, it can be written as pi over 20. It can be written as 0.46 in terms of decimal. Because this is a 0 degree, this is a 0 degree, this is a 0 degree. Now in degree, this angle is 90. But here this one is, it's not 90, it's called pi over 2. And in the same way, in decimal, this will be 3.14 divided by 2. So that is equal to, so this is equal to 1.57. Now this is 180 degree. So this is pi, and this one is 3.14. This is 270 degree. This one is 3 pi over 4, and this one will be 4.71. So that is how we convert it between degree, radian in terms of pi and in terms of, when radian is written, if it is say pi over 3, 2 pi over 4, 2 pi over 5, 6 pi or whatever, we don't write radian, it's obvious. But when we write 0.23, either we write RAD or we write 0.23. This, it means it's a radian. C stands for circular measure. That's why we write it this thing. Now suppose we have 60 degree. Now how we convert it into radian and radian. So now we know that this 60 degree, if we convert into this, that is 60 degree roughly. We know it's roughly more than 1 radian because 1 radian is 50 cents. So how actually we convert? So we do it 60 pi over 180. So this is pi over 3. And if I have to convert it into decimal, it is 1.4, it is 1.047. It is 1.047. So now you can see that 60 degree can be converted into radian in terms of pi and in terms of decimal also. If you have to convert, say if I have to convert this one again, say again I am taking the same question, 0.46, this is a radian. If I have to convert it into degree, this if I have to convert it into degree, then I have to use calculator for that. Now if we have to convert 0.46 into degree, what we have to do is 0.46. We know our 1 radian is here, this is around 57.3, that is 1 radian. So 0.46 is roughly here. So it is somewhere in between. We know this very well. So what we are going to do is 0.46, this is this part, and this total part is, this one is, that we call as instead of unit circle, so it is pi multiply 180, and that you will get 26.35, you can write it 26.4. That's how we have to calculate this one. So this is easy. Let's take some more examples. I told you the formula earlier, that the formula was that degrees we calculate 180 and radian is pi. Now for example, we have 2.5 radian, so we have radian, we have to find it in degree. So degree is radian multiply 180 over pi, the same we have done it here. So that is equal to 2.5 into 180 over pi. Now if you know the circle, just to give you an idea, this is 2.5, 1 radian is around roughly 60, 57.2 radian is around 120, and 0.5 is another 30 degree. So let us see it's equal to what. So that is equal to 143.24. So 143.2 degree. So that is equal to 143.2 degree. So you can see that we have degree, we have radian in terms of pi, and we have radian in terms of decimal numbers. So it's very easy to convert in between. If we have a radian and we want to convert it to degree, simplify. The simple method is, if it is this way, multiply that radian by 180 and divide it by pi. If you have to convert degree into radian, you divide it by 180 and multiply by pi. So this is from radian to degree, and this one from degree to radian. And furthermore, if you have to write it into this, then put pi is equal to 3.14.
That's all for today. Thanks for watching.